Hey guys, welcome back. Alright, so we've actually been working for a few hours. Hasn't been super productive, but we're working on the cooling system. I finally made enough progress, I thought I'd show you. So, last time we worked on our pump, we got our barb fittings hooked up, and here's how it's looking. So, we got cold water comes out of our radiator, goes through this hose, and into the inlet of the pump. Now the pump's in the bottom so that when you fill this thing with coolant, the pump, you like to prime the pump, so having the pump down low is good, so it gets a good prime. So, and also it's on the cold side of the radiator, which is also good, less heat into the motor of the pump. Anyway, cold water goes in the pump, cold water goes out of the pump, pipe comes up, over, and back, and this plumbs into our bracket we made. This is our electric water pump conversion, so we built this bracket. I need to sell these. I need to make some more of these. But anyway, I'm going to sell these. If you ever want one, let me know. But this bracket, well, it bolts up, does our timing belt. It's got a tab over here for an alternator, although I'm not using it, so I use that for my reroute. But anyway, our cold water goes right in there, just like on a regular water pump. Cold water would be going into the pump and into the block right here. And as you can see, we got a nice stainless pipe. Now, it's not welded yet. I just cut the pieces and taped them together for a mock-up, because we're really not done. We got to do another one, but this is kind of cool. So the way our reroute worked out, here's hot water coming out of the back of the head. So there's a stainless pipe, runs underneath the intake manifold. Maybe this will show up on camera. Yeah, there it goes. Shoots right over the starter motor. And if we go to the back, we can see it makes a turn, and I have a thermostat housing. This is kind of I think it's a cool setup. You don't see, I've actually never seen it done exactly how I just did it. So there's a couple things of note. For one, I have a reroute without a spacer. When was the last time you saw that? So this thing is super compact. What I did, there's normally a fitting that goes right there. Let me get the camera in here so you can kind of see. I put a freeze plug there. So this piece of metal used to exist and poke out and be all up in the way. And it's pressed into the head. It's a little bit of a pain to get it out, but then I got a freeze plug, and red Loctited it into the head. This other bolt, it was actually clear, but you can see I put a notch in it anyway to give it a little extra room. And that particular housing is clocked the right way. And so if we look here, you'll see there's a gasket. The thermostat, the front of this back of this head actually has a notch right for a thermostat. So the thermostat's actually in here, so it's, you know, the hot water, thermostat, gasket, housing comes back, and there's just a little straight piece of silicone that goes here. It's just not installed at the moment. Got a brace that catches that bolt to support it, and that's our reroute. Admittedly, this took forever to figure out, but I like it. And one other thing I'll show you, if we come back over here, I did make this modification. So the back of that, hard to get the camera in here, I had to weld on a bung. It's hard to see, but there's a hose hooked to it. So that hose, if we look like this, loops around and goes to the turbo. So I've got hot water, or whatever water, going in and out of the turbo. So cold water goes in the block, and a little bit of it goes straight up and into this fitting. So this water is fairly cool because it's only traveled like 3 inches. And then it goes through this hose into the turbo. That cools our turbo, and then it shoots over to the back of the head, and then it can circulate through that main pipe where it's going to loop and go to the radiator. So we haven't done that part yet. The only downside to doing this is for thermal siphoning. But here's the thing, I have an electric water pump, so it's not a problem. I can shut the engine off and run the pump and cool everything down that way. So it's really not an issue. And of course the turbo water cooling is independent of the thermostat circuit, so that's nice. Let's go over a couple other things. Here's a heat exchanger, may have noticed. This is for the transmission. So I can get this in here. You'll note these black fittings, these are 6AN, so our transmission, doubt I can get this on video, but somewhere back there in the transmission, there's some 6AN fittings. Those are, actually they're taped up. See that white, that piece of white tape there? Anyway, that's a 6AN fitting. It's just taped to keep it clean. But those have some AN lines that'll go up to here to this heat exchanger. This is a liquid to liquid heat exchanger. These are 1/2 inch hose barbs, and I just got to get those plumbed in. So we haven't done it yet, but let me explain how this is going to work. So if you just pump cool water through this heat exchanger, it's just going to cool the transmission. that sounds perfect. But what if you don't need to cool the transmission? What if it's needing to warm up the transmission, or you don't want to overcool it or whatever? Like, anyway, like on an engine you have a thermostat. So for this, they make thermostats, and in fact I purchased one. I have it right here, but I'm not going to use this. I don't like it. I don't know. Maybe it works. I took it apart, I studied it. I'm not really sold on that. It kind of works maybe, but I want to do something better. So what I'm doing, I'm going to have a circuit. I ought to have a diagram, but this will make sense. So here's your water pump. Cold water coming out of the pump right here, right? This is our source of high pressure cold water. I'm going to put a pipe that comes right off of here, and we're going to send high pressure water into this heat exchanger. Right? So we got high pressure cold water going in, and when it comes out, it just goes right back into this pipe. This big old pipe is going to go right to the top of the radiator. So that way you'll have a loop of cold water from the radiator, goes in the pump. As soon as it comes out of the pump, shoots over here to our heat exchanger, comes out of the heat exchanger, hits this big ass pipe, and goes back to the top of the radiator. So that way, no matter what, you have a continuous loop of water circulating like that. It doesn't go through the engine. The source is as cold as it could be and as high pressure as it can be. Most delta P, so you get the most flow rate. But the only problem is, what about overcooling the transmission? How do we solve that problem without using a thermostat? So let me show you what we're going to do. This is what we're going to try. So I found these valves a while back. I actually bought these at work. This is actually from work. They gave me a bunch of these. But anyway, this is a ball valve that you can control. It's actually cool. It's just 2 wires. So you just give this 12 volts and it opens. And what's kind of cool, I haven't studied exactly how it works, but this valve, say it's open and you lose power, it'll automatically shut. Now in this case, being shut means the transmission would get hot, but I think they make it both ways. I think it's just like a safety feature that it closes automatically. Anyway, 1/2-inch ball valve, so I can either totally open or totally close this flow path. Don't know if this is, I kind of see that. So the ball's closed now, so you can't see through there. Obviously, if it was open, that would be a straight hole right through. The only thing worth mentioning, these fittings I bought are kind of janky. So that hole, even though it's a 1/2-inch barb, it's kind of small. I may go back and drill these later, but I'm going to try not to do that right now. But anyway, got these fittings in. We actually modified the fittings. That's boring. Let's not worry about it. But this is our ball valve. This thing's rated to like, I don't know, about 100 degrees Celsius or so, something like that, and like 80,000 actually it might even say on here, I don't remember. Anyway, there's the valve if anybody cares about the specs. Yeah, 100C. Anyway, pretty cool. We're going to use that, and we'll just have that controlled by probably the ECU or an Arduino or something, because really we want to vary the cooling with transmission temperature. So we have a temperature sensor in the transmission pan. So basically we'll send that signal to like an Arduino, calculate, using whatever it is, input, analog input, get our temperature, write a little code to turn that valve open and shut based on, temperature. So that way we can keep our transmission nice and cool, and it's basically completely separate from what the motor's doing. So kind of nice. And also the capacity. This should be very high capacity. We got 1/2-inch water lines. This is a big ass heat exchanger as far as the plates go. That thing has a lot of thermal capacity, and we have the entire radiator's worth of cooling system available. And we have a giant pump. Like, this pump is huge. So say you just made a pass and you're, trying to cool the car off, you're idling it back around, there's so much cooling capacity to get that trans cooled off quickly. And that's what I like about this setup. It's like, there's other ways to do this that would be effective, but this should be highly effective. A lot of ability to remove heat. We'll see how it works in real life, but that's the hope. So anyway, that's kind of how the system works. The next thing we got to do is connect these two. So this pipe just goes right there. I did make one little oopsie that in hindsight I shouldn't have done. I made this so short, which was kind of on purpose, but because I didn't have the bolt here at the time, I could get a low profile bolt, but basically this is so short I can't really stick a hose on that. So what I'm probably going to do is weld something and make like a little S curve here, and then put a length of silicone that goes right there. But one thing you'll notice when I'm building this is I'm leaving the length of silicone kind of long. This one is a little bit short, but there's actually some room in here to move. But then if you come down over here, like this one on the bottom's long, That one's kind of long. That's because the engine, you know, is going to move around and torque and twist and whatever. I don't want to be stressing any of the metal pipes and possibly damage them, cause cracks or, you know, whatever. These are coolant pipes, not motor mounts. So that's important so we don't end up with like fatigue failures and overloading, cracks, stuff like that. So anyway, we're gonna work on this top pipe. That bottom one's mocked up. Let's get the top one mocked up, and then we'll take all these off and get them welded.